Hey everyone. Today we're going to be taking a look at equations and identifying their graphical properties from them. So, and without the use of Desmos or something like that, you can use it definitely as a tool to support, but make sure that you have the ability to find these properties from looking at the equations or the graphs. And there's even going to be part of this where we're going to try to graph something from scratch, given what we know about transformations and periodic functions. So this is going to be the worksheet that we're working on. This wasn't necessarily within the packet. It was attached, or it was a separate sheet. It's also on your calendar, which you can download if you need to. But yeah, so just kind of go and find it there, and then we should be all set. Before I kind of show you a couple of these, which you might already have the skills for, I just want to highlight, one of those things that we're doing in mathematics overall, and that is finding a way to relate all of these various pieces together. So within our units, this is something that I'm generally looking to do, is find a way to connect all these various components to one another, so that if we have a table, we could come up with an equation or a problem situation. Yeah, actually, that seems a little arrow heavy. But if we have these things, then we can come up with all the rest of them, okay? So there's nothing that's kind of missing. If we have a graph, we can come up with an equation. If I have a problem situation, I can come up with a graph, so on and so forth. And then all that's really changing in math are kind of the topics. So initially, if you were in algebra, you were just talking about linear stuff and being able to relate everything along those lines. No pun intended. But now, obviously, within this lesson, we're talking about trig and periodic functions, and how do we get all this information kind of moved around. So today we're going to be taking a look at getting from the equation to the graph. Maybe, I mean, that's probably our primary focus. I guess we've also got from graph to the equation here as being helpful, but that's really going to be kind of our focus on the day. Whereas tomorrow we're going to be taking a look at getting from the problem situation to the equation. And I think we've even done problem situation to graph already with this. We've kind of left the table out of it ever since pretty much, some of the earlier days, but maybe it's something we can go and take another look at just to make sure that we have it. But that's kind of a basic premise of what we do in mathematics. And sometimes we'll stay in one field for a little bit longer. So, after we're kind of done with all this converting to and from, we're going to spend a lot of time working with trig equations. That's, the second part of this unit. I really consider it to be like part 1 and part 2 when we talk about trig. But you'll get a sense for that on Thursday. So just wanted to kind of bring this to our mind just because I didn't want folks like losing sight of kind of this overall goal. All right. So at the top here, like I said, we're going from equation, and while we're not going to necessarily graph these, we should have all the tools to graph them once we can come up with these characteristics. So we're going to look to identify the vertical shift. So that's if something was kind of moved up or down. This is the horizontal shift. We talked about that as being the phase shift as well. And then we have our amplitude and period. Another thing that we might kind of know vertical shift as is basically our midline. So when we move a periodic function up and down, we're directly changing that midline. So those two are kind of synonymous when we talk about transformations. And what I'm going to do is probably just choose maybe 2 of these. I'm taking a look and just kind of eyeing maybe 6 and 2 here, just to get a sense for how we're going to be answering these questions. But then otherwise, the rest of the worksheet is kind of worth struggling over. or coming up with, and then we can check and see how things are looking on Thursday. So if I look at question 6, I'm looking for, is there a vertical shift, horizontal shift, amplitude, or period? And all of those have to basically coincide with this equation that we've been looking at in transformations and on our worksheets to understand all of those. So for a vertical shift, I'm primarily just looking at that D value here. So this does have a vertical shift, and I will say down 2. So very similar to transformations here. Horizontal shift would be my C value. Again, we might be calling it a phase shift at some point. I don't have a phase shift in this point, so I would accept none or potentially even 0 here, is, if we want to keep it in the numbers realm. So we weren't moving this thing left or right at all. By comparison, even though I'm not going to be jumping into that problem, this is going to be looking like a horizontal shift or phase shift. And just remember that if we're subtracting something, we're actually moving to the right. So this would just be actually to the right by pi radians, because our x-axis is either going to be in degrees or radians primarily. Our amplitude is governed by our A value. Generally, our amplitude is a 1 for sine of x or cosine of x. So when I have this 2 out in front, that's going to end up scaling this by 2, or I'm going to end up with an amplitude of 2. So similar to a vertical stretch. And then finally we have our period, which is going to be this governed by this B value. It's not it's not directly B, so maybe I'll put related to, because I don't want you thinking that our period here ends up being 2. So our period, if for sine or cosine, the period is 2 pi divided by your B value. So our period here is 2 pi divided by 2, or pi. Okay, and we had looked at examples like that yesterday, but we can also tell, if this is a horizontal compression, okay, same thing as previous transformations, this is a horizontal compression by 2, means that sine function is going to complete in half the time, or in half the amount of radians. So normally if it completes in 2 pi, now it's going to be completing in pi. All right, so this is pretty much the general lineup of what you're going to be doing. Easy to come up with vertical shift, horizontal shift, amplitude, and then when you get to period, there's just this slight amount of math that you're going to need to go through in order to figure that out. Problem 2 up here is a little bit easier, and mostly I just showed that because overall I don't think that any of this is too complex. But this is just going to show you how to do kind of a baseline example. So vertical shift governed by our D value. So we don't have one of those. So, 0 or no vertical shift. Horizontal shift governed by the C value. We don't see one of those. So we're going to put in 0 here. Our amplitude is, identical to our A value. So that's a 3 for this. And again, we could call that a vertical stretch by 3, or we can just say that the amplitude is 3. And then finally our period. And don't lose sight of the fact that our period, still has this same equation. So we would say that our period here is 2 pi because it's unchanged, but the original period of sine is 2 pi. So that's why we're going to keep it like that. So within this worksheet, there's some converting between equations in our properties. Here you're just going to be doing, determining amplitude and period of these functions. On these graphs, what we're going to be doing is, so you're going to take problems 6 and 7 from the first page, okay? And you're going to try to graph those. But I've also requested that we graph sine of x on these. So sine of x, we should be able to start coming up with a little bit more, just kind of like we know what it looks like, but I know that ends up still being a little bit of a trick for folks. But this is what sine of x would look like. Our scale's a little bit off from what we might be working on in terms of the y-axis, so it might not appear as steep, but this is kind of our basic sine of x graph. And the reason why I wanted this is I really wanted you to treat this like transformations. So for problems 6 and 7, if you can identify the order of transformations, remember we came up with those steps, then what you're going to do is try to apply those steps to this graph, okay? So very similar to transformations, you should have all the tools kind of necessary in order to come up with them, but it's also something that we can take a closer look at on Thursday. If you want, you can use Desmos here, but use it as a check versus as a primary resource. And then the last piece of this, here we're going from graphical properties kind of to an equation. So that should be also a nice little mix here, right? So we don't have a lot of graph to equation on this, but the 14 and 15 should supply that for you. All right, that's the kind of entirety of our work today is this worksheet. I don't want to start us up on the next kind of piece to this just because I want to be there for that, even though I'm going to do it on the Zoom day. But yeah, good luck. Thanks.